Reliability enhancement. What we do in reliability enhancement, we just enhance the reliability of our component. Suppose we have a reliability of 0.9 and we enhanced it to 0.91. So why we do this? We do this because we have to find out which is the lowest component, the component with the lowest reliability we have to work on. So the first thing that we have to find out is which is the component I have to work on, the component that has the lowest reliability. And the other thing what we find out is that how much delta R0 reflects on delta Ri of the components I have to increase. So we have, suppose, R of 0. We have a reliability R of 0 at time t. So when we enhanced our reliability, what we do, we enhanced it to t star at time t star. So what we get, R0 plus delta R0. This is the form that we enhanced. So by enhancing our reliability, we have to find out first that which is the component I have to work on, like the component that has the lowest reliability I have to work on, and by increasing delta R0, so how it gets affected on delta Ri of the component I have to increase. Like first, suppose we have the component delta Ri that I have to increase, that I have to work on. So how it gets affected? So first of all, what we do for that, we have a formula. We know that in series block diagram, we have the products of all the components. We do the product of all the components. So when taking the R0 plus delta R0, we have a formula R1 R2 times R3 times Ri minus n times Ri times Ri plus 1 times R of n. So when after enhancing our reliability to R0 plus delta R0, what we got, R1 times R2 times R3 times Ri minus 1 times this Ri goes from Ri plus delta Ri when the reliability is enhanced. So R and the rest is the same, Ri plus 1 times R of n. So the equation, by simple multiplication, we get R1, R2, R3, Ri minus 1, and this Ri multiplies with the whole term first, with the first part Ri and Ri plus 1 dot R of n, and the other plus sign here, and the rest we write as R1, R2, R3, Ri minus 1. See, Ri minus 1, minus 1, and delta Ri. This one delta Ri comes here, and the rest Ri plus 1 and dot R of n goes in the same way. It's as it was. So we have another form to represent this whole equation. Like we can represent this whole equation. It's a quite lengthy one. So we can represent it in this form also. So what we write now, delta R0 equals to delta Ri times the product from j going from 1 to n, and j is not equal to I. This I and j are not equal. So j going from, what is the limit of j? J going from 1 to n, j not equal to I, R of j. So this is the first thing that we find out. From this equation we got this. We enhance it simply. Not enhanced it like we just it seems so big and large. It doesn't suit our eyes, and so we put it like this, because it can also be written like this. Now what is the next step? Now what we will do, we see that We have to find out Ri. We have to find out the lowest component, the component which has the lowest reliability. So now what we will do from this, we will just take delta Ri, see delta Ri over delta R0 over delta Ri. This delta Ri goes down there, right? When it goes down there, we have got this term, this delta cancels out, and what it becomes now, R0 over Ri. See, R0 over Ri. So this thing becomes now like this. And what we find out now, what we have to do, we have to take this delta R0, again this equation delta Ri, and we have found the value of this, like R0 over Ri. We have found the value of this, so we keep the value of this, that is R0 over Ri, here in this equation, and we name it as equation 1. Okay, got it? We named it as equation 1. And we also find out that delta Ri is the lowest component that we have to work on. So delta Ri, we got this equals to, this equation can also be written like this, like delta R0. If you have to find out delta Ri, this equation can also be written like delta R0, and this Ri goes there and got multiplied with delta R0, and this Ro, it goes in division here, and we got this thing delta Ri as this. So what we find out now, that